Hi, I'm Miss Hearn. Let's get started. In this video, we have a complete lesson on multiplying and dividing rational expressions. Rational expressions are just fractions with variables in them. So let's refresh our memory on how multiplication and division of fractions works when you just have numbers. It's going to be very similar when you have variables. So let's start with 3/4 times 2/21. So multiplication of fractions is actually the easiest of all the fraction operations because it just goes straight across. So one way you could work this problem would be to multiply 3 times 2 and get 6, then multiply 4 times 21 and get 84. But then you would need to reduce at the end. So usually what we do instead is we kind of reduce as we go along. What I mean by that is 3 has a common factor with 21. And so we go ahead and say 3 goes into 3 once, 3 goes into 21 7 times. And similarly, 4 and 2 have a common factor of 2. 2 goes into 2 once, 2 goes into 4 twice. Then multiply across. 1 times 1 is 1, and 2 times 7 is 14. And this fraction's already in lowest terms, so we don't have to reduce any further. For division of fractions, let's look at 6/25 divided by 33/35. All you have to remember about division is keep, change, flip. Keep 6/25, change the division to multiplication, and then flip 33/35 over and make it 35/33, the reciprocal. Then the rest is just like the previous problem. Reduce as much as possible. For example, 3 goes into 6 twice, and 3 goes into 33 11 times. And 5 goes into 25 5 times, and 5 goes into 35 7 times. Then we just multiply straight across. That gives us 14 over 55. It's always good to check to see if there are any common factors we can reduce between 14 and 55 at the end here, but there's not. The prime factors of 14 are 2 and 7. The prime factors of 55 are 5 times 11. We don't have any primes in common, so we can't reduce any further. In other words, we've simplified our answer as much as possible. Let's try the same thing, but with variables. So here we're going to multiply 5y times 8b to the 4th y, and 4b cubed times y to the 4th. We do have the option of simplifying first or simplifying at the end. Let's suppose I decide to simplify this one at the end. Then multiplying straight across, you're going to keep in mind that when we multiply like bases, we're going to add the exponents. So 5 times 8 is 40. b to the 4th, there's no common base, no like base, so it just stays b to the 4th. And y to the 1st times y to the 1st is y squared. So we have 40 b to the 4th y squared. Now in the denominator, all we can do is write 4b cubed y to the 4th. You can only multiply exponential expressions that have the same base. And you do that by adding the exponents. Now let's reduce. So 40 divided by 4 is 10. And 4 divided by 4 is just 1. And then b to the 4th divided by b cubed, since there are 4 factors of b in the top and 3 in the bottom, 3 of them cancel out that are in common, leaving just 1 left in the top. Y squared over y to the 4th, there are more factors of y in the denominator, 2 more than in the top. So we're going to have 2 left. In other words, I got the exponents by subtracting. The b had a power of 4 over a power of 3, so 4 minus 3, and it was left in the top. Y had a power of 4 in the bottom, which was larger than the number in the top, so we did 4 minus 2 and left it in the bottom. We never write a power of 1, so I'm just going to write this as 10b, and then 1 times y squared is just y squared. And there's our product. Let's work another problem with a product, and then we'll do a quotient. I'm going to reduce a little bit first, but some things I'll leave to reduce in the end. It's really up to you how far you want to take it when you reduce in the first step. So for example, I noticed right away that 5 goes into 15 3 times, and that 2 goes into 2 once and 2 goes into 4 twice. I also noticed that we have a copy of b in the denominator, and in the numerator, b divided by b leaves just a 1, so those cancel out, in other words. But I think I'm going to leave the x's to the next step because I want to put the two together that are in the top, and then I'll worry about the exponents. So we'll have, let's see, 1 times 3 times 1 is just 3, and then x times x is x squared. And then in the denominator, I'll have 2 times x to the 4th. Now let's go ahead and decide, are we going to have more x's left in the bottom when we cancel out or in the top? So right now we have 4 copies of x in the denominator and only 2 in the numerator. So when we divide out those common factors, we're going to have some left over in the bottom, right? And how many are we going to have left in the bottom? Well, we can decide that by subtracting the number in the bottom minus the number in the top, which leaves 2 left in the denominator in the bottom. So we have 3 over 2x squared. Next, we're going to do a division problem, which is really going to turn into a multiplication problem because we're going to apply the idea of keep, change, flip. So I'm going to rewrite this exercise as 3x to the 4th over 10b to the 4th x, keeping that the same, change the division to multiplication, and then flip, finding the reciprocal of the second fraction, the second rational expression. All right, now let's see if we can reduce a bit before we go ahead and multiply across. I noticed that 2 goes into 10 5 times and 2 goes into 12 6 times. So that's something we could reduce. And I think I'll leave the rest for at the end. That's up to you though. So 3 times 6 is 18. And then we have x to the 4th b cubed multiplying straight across in the numerators. In the denominator, we're going to have 5 times b to the 4th, and then x times x is x squared. Now, I already reduced the numbers as much as possible, but we have some work to do on the variables. So let's look at the x's first. So x to the 4th is in the numerator, x squared is in the denominator. We have 2 x's that are going to be left in the top when we cancel out 2 of them from the bottom. And then the b's, b to the 3rd over b to the 4th, there were more b's in the bottom. So if we cancel out the 3 that were in the top, we're going to be left with just 1 in the bottom. So we have 18x squared over 5b. So each of these last 3 problems were an example of multiplying rational expressions that contained monomials, one-term polynomials, in their numerators and denominators. In other words, there was no addition or subtraction going on. So those are kind of handled differently than something like this. Here we're still multiplying 2 rational expressions, but you see the subtraction going on in these. So that means that we have to be very careful. There's a common error where people think that they can go ahead and say, divide the 8 by the 2 and get 4, and that's just not true because 8 is part of a term. It's not an entire factor. Only factors can be canceled, not terms. So what we need to do is to think of this as one big factor, and this is one big factor, and then see if we can factor it out a little bit further. So right now I can look right here and see that 8x and 64 have something in common. They have an 8 in common. And if I factor that out, it leaves x minus 8. And down here, where I have 2x minus 16, these two terms have a 2 in common. So factoring out the 2 leaves behind x minus 8. So I'm going to rewrite this as 7 over 2 times x minus 8 times 8 times x minus 8 over 5. And then I'm going to proceed like I have in the previous problems. I'm going to multiply straight across, but before I do, see if I can reduce anything. For example, x minus 8 goes into x minus 8 once in the numerator and denominator. 2 goes into 2 once, and 2 goes into 8 4 times. And that's about all I can see to reduce. So let's go ahead and multiply straight across. 7 times 4 is 28. 1 times 5 is 5. So we're left with just 28/5. Let's try one where we're dividing. The keep, change, flip idea still applies. So let's rewrite this as a multiplication problem. This is going to be 7 over 3x minus 27 times 9x minus 81 over 5. And then we're going to recall that we should factor completely so we can see what we can reduce here. So thinking of this as one big factor and this is one big factor, let's see what they have that we could factor out of them. So the 3x and the 27 have a factor of 3 in common, and what's left behind is x minus 9. The 9x and the 81 have a 9 in common, also leaving behind an x minus 9. Let's rewrite what we have so far and see if we can do any reducing. This is equal to 7 over 3 times x minus 9 times 9 times x minus 9 divided by 5. So let's see if we have some common factors. Well, 3 and 9 do, right? 3 goes into 3 one time, 3 goes into 9 3 times. And then x minus 9 divided by x minus 9 just leaves behind a 1. And that's about it. So we're going to multiply straight across, and we have 7 times 3 is 21 over 1 times 5 is 5. Now, in both this problem and the previous problem, the result in the end reduced down to a number, a numerical fraction that didn't have variables in it, but that's not always the case. Sometimes there'll be variables left in them. Let's look at this example. Again, we're doing division, so we're going to keep, change, flip. So I'm going to immediately rewrite this problem as x minus 8 over 4x plus 16 times 8x plus 32 over 3x minus 24. But the next step is to factor. There's not much we can do with this until we have factored. Think of the numerator, in this case x minus 8, as one big factor. There's nothing in common to the x and the 8, so I'm just going to leave that the same. 4x and 16, though, have a factor of 4 in common, so I'm going to factor out a 4, leaving behind x plus 4, times, in the upper right, we have 8x and 32, which have a factor of 8 in common, leaving behind x plus 4. And on the bottom right, we have 3x and 24, which have a 3 in common. So I'm going to factor out a 3, and that leaves behind x minus 8. All right, now let's see what we can reduce before we multiply across. X minus 8 goes into itself once. X plus 4 goes into itself once. And I also notice that 4 goes into 4 once and 4 goes into 8 twice. Now multiplying straight across, 1 times 2 is 2, 1 times 3 is 3. And we're down to just a numerical fraction again. Again, that doesn't always happen, but in these problems, it's working out nicely. Let's look at one more. This one's a little bit more complicated because the factoring is going to involve procedures for factoring a trinomial, which is not just a GCF anymore. All right, we're multiplying, so we can multiply straight across, but first we should factor and reduce. I'm going to come off to the side and factor x squared minus x minus 6. There is no GCF for these three terms, and since there are three terms, this is a trinomial. Many people have different ways of factoring trinomials, but I always teach my students the AC method. This is your A, your B, and your C. So A is 1, B is -1, and C is -6. What you do with the AC method is you multiply A times C, which in this case would give us -6. And we look at all the factors of -6 and we look for a pair that adds up to B, which is -1. For example, 1 times -6 is -6, but the sum of those two would actually be -5, not -1. -1 times +6 would be -6, but that would give us a sum of 5. 2 times -3 would give us a product of -6. And that sum is actually 2 plus -3 equals -1, which is equal to B. When you find the pair that multiplies to give you -6 and adds to -1, you normally split the middle term and use grouping if you're using the AC method. But the nice thing about the AC method is if the leading coefficient happens to be a 1, if A is 1 in other words, you can just use these two numbers to factor the expression. So we're going to factor x squared minus x minus 6 into x plus 2 times x minus 3. We're going to leave the x minus 1 the same. That can't be factored any further. X plus 1 can't be factored any further. But 4x plus 8 has a GCF of 4. So I'm going to factor out the 4, leaving x plus 2 behind. Okay, so this is really the same problem. I haven't changed any values. All I did was write it in factored form. Now we would multiply straight across, but I am going to reduce as much as possible first. So for example, x plus 2 goes into x plus 2 one time. X minus 1 and x plus 1 are not the same factors, so you can't reduce them. So there's nothing we can do with those. X minus 3, there's nothing we can do with that. And the 4, there's nothing we can do with that. So multiplying straight across, we have x minus 3 times x plus 1 over, and then we have 4 times x minus 1. Now, sometimes in some online homework systems, or if you're working on multiple choice tests, they might have this multiplied out in the numerator. So let's just practice really quick. When you multiply two binomials, you have to FOIL. So first times first would be x squared. Outer times outer would be x times 1 is x. Inner times inner would be -3x. And last times last, -3 times +1 is -3. So this numerator is x squared minus 2x minus 3 when we combine these like terms. X squared minus 2x minus 3. If you wanted to multiply out the denominator, you would have 4x minus 4. But really either of these is correct. All right, let's do one last problem. We're going to divide now. And we have x minus 2 over x squared plus 3x plus 2 divided by 3x minus 6 over x squared plus 5x plus 6. Maybe you could pause the video now and try to work this one out on your own. See if you've got it. Okay, we're going to use keep, change, flip. And I have factored each of these polynomials. I'm going to keep x minus 2 over x plus 2, x minus 1. Change the division to multiplication. And then we're going to flip this so it will become x plus 2 times x plus 3 over 3 times x minus 2. Now we want to multiply straight across, but I'm going to reduce before we do that as much as possible. X plus 2 divided by x plus 2 leaves 1. X minus 2 divided by x minus 2 leaves a 1. And that's about all we can do. So in the numerator, we're going to have x plus 3. And in the denominator, we'll have 3 times x minus 1. Or if you're asked to multiply that out, you'd have x plus 3 over 3x minus 3. I hope you found this video helpful. If you did, please remember to give it a thumbs up. When you like it, that helps other students to find the video.